Hello, in this demo, we're going to design bone reduction guide, surgical guide, and a prosthesis guide for 4-on-6 case. This is a regular 4-arch case. We have placed 6 implants, 3 anchor pins, and we have loaded radiographic guide and registered with the patient CT scan. In order to have a good prosthesis guide design, we want to load the denture design first. It's a digital denture design, or it can be an optical scan of a denture. So we load the STL file of the denture design. Starting in this version, we have included the model fix function. So you can use that to fix typical STL file quality issues. That's in this menu. If you right-click on any STL file or model, you will see a global model fix that will fix the typical problems like reverse normal, overlapping triangles, small holes and gaps, etc. So for this denture design, it actually has a good image model quality, so we'll skip that step. And we can right-click on this and tell the system to register this model with the radiographic guide. With this registration function, GuideMia can actually register as many models as possible as you like to. So this is a regular registration process. We specify 3 pairs of points, so the system can start put the models together. This is a dynamic process. If we accept the results, we can just continue. Otherwise, we can add additional points to this process. For example, if we want to add a point from here, so we can have a better registration on this point, then we can add a point here. So system will update the registration until we like it with a finish. As usual, system will tell us how accurate the registration is. As far as the bone reduction design is concerned, GuideMia always design a bone reduction guide that sits on the patient's bone structure. Given that said, we do need a good bone model instead of just a filtered bone structure. The reason we always design bone reduction that sits on the patient's bone structure is that it's much more stable, and the guide will sit on the patient's bone structure even without anchor pins. So that will give the surgical guides more stability and more accuracy, of course. One of the things with 4-arch cases, especially for upper jaws, we very often would have low bone density and loose bone structure. As usual, we would need to use this function called tissue pinning to simulate the tissue pinning process to have a better bone structure. Typically, this value will be starting from 1.5 millimeters to 3 millimeters, depending on the bone density and also on the slice thickness of the case. We have done this in the preparation stage, planning stage, but we can take a look at how the bone structure is with this function applied to the original CT data. Now let's take a look at the current plan. We have placed all those implants, and we can evaluate the implants and the surrounding bone structures with functions like this. So we can review the implants one by one, like that. Then, of course, we have surgical kit configuration. We have other tools in this tab. So as a new feature in this version, the surgical kit configuration tool is moved here and the users can save their surgical kit without administration privilege when you run the system. Now, bone reduction has been moved to the treatment planning section here. The advantage of doing this is when we are in the bone reduction, we have access to all the geometries, all the models and implants. So we might have better reference when we perform the bone reduction definition than just the bone structure in previous versions. Of course, we can just show and hide any models we want to. Now, the bone reduction is pretty simple. First, we define the area we want to perform the bone reduction. Say we want to trim the bone on the anterior area. Then we define how deep we want to cut. When it's too deep, we can adjust the height. And also, as a new feature in this version, we can now save this tool body, so you don't have to redefine the bone reduction every time you want to modify a case. But for now, we are cutting into this plane. And if we feel like to, we can continue. But if not, we will adjust. Of course, for now, because the bone reduction plane needs to be a little lower. Then we will say, okay, preview the bone reduction, meaning we are going to actually trim the bone structure and create a bone model with this area removed. Bone reduction, reduce the bone structure and also view original bone structure by turning on and off this cutting plane. This way, you have a better idea where we are cutting the bone structure. Now we go to bone reduction guide design. With this version, we have combined the surgical guide page and the bone reduction page into one single workflow. So you no longer need to switch to the bone reduction guide page. All you need to do is to select bone reduction guide. The system will return to the bone model. And as usual, we will cut the bone structure as the base for surgical guide design. What circular area we want. We cut this. So after multiple cutting, we will have a good base for the surgical guide. Do another cutting. As usual, right, the clockwise profile will keep the materials inside. And we cut this. Bone reduction guide, it's automatically turned into Plateau guide. All you need to do is click this button. It's going to generate the 3 guides in one step for you all automatically. And we generate the surgical guide by cutting this area, and we generate the prosthesis guide. And if we rotate this view, we can tell that prosthesis guide is used to sit onto the patient's bone structure, and bone reduction guide so that we can use to check the occlusion. We can make sure we cover all the anatomy when we define the cutting area, so we can make it bigger. But if there is anywhere that's not very necessary, we can make it smaller too. This is one of the example that we don't cover this area enough when we define the bone reduction area, but for occlusion checking purposes, this is still maybe good enough. And this piece, purple piece hidden behind the prosthesis guide is the surgical guide, and we can tell the prosthesis guide has an area that's sitting on the bone reduction guide. So that's how all the three guides are together. If we go back to the planning page, we can inspect the guide one by one. So that's our combination of bone structure, bone reduction guide, surgical guide, and the prosthesis guide. In actual production or actual surgery, you can further trim this model so we don't have to cover this much on the lingual side. As usual, we have lots of functions in GuideMia to do this kind of post-processing. And if we want to check the individual models, bone reduction guide, that is our surgical guide, and that is our prosthesis guide. Now we go back to the guide design. There needs to be a connection between the surgical guide and the bone reduction guide, as well as the prosthesis guide and the bone reduction guide, so they can be properly assembled together at the surgery time. So it's a very simple process here. All we need to do is we need to click on this Add Connection button. Then we can click on the screen and to add a connector on this base, on this bone reduction guide. You can add a block here, you can resize this block, and then you can add multiple. Typically for this case, I would add maybe 4 or 6 connectors. Now let's take a look at what happens with the surgical guide and the prosthesis guide. You can tell here, we also add this connector on the prosthesis guide, and so we did the same thing for the surgical guide. So this is how they would click together. So this prosthesis guide will simply sit on the bone reduction guide. Okay, so this concludes our demo. In another demo session, we're going to introduce the new design when we have very low bone density, very loose bone structure. How can we combine either tissue-based and bone-based model as a base for surgical guide, or we can do multiple bone segmentations and combine them into one single piece for surgical guide. So look forward to the second demo, please.